So given here are three different compounds. So all of it are alcohol. So how are you going to check that this is indeed alcohol structure? So you need to look at the functional group of all this structure. It have the OH functional group. So we can confirm that all three compound here is indeed the alcohol. So what else that you need to know? So you need to differentiate between whether these compounds are primary, secondary or tertiary alcohol, because they will react differently among each other or with other additional reactants. So how are you going to know whether this is a primary, secondary or tertiary alcohol? So first you need to find the carbon that have your functional group, your OH. So in this case, the first one, you're going to look at this carbon. So we're going to put a star here. Right. So for a primary alcohol, it only have one R, one substituent. So if you bracket this one, this is your R. Doesn't matter how many carbon you have at the end, it doesn't matter, because we are going to take this as a chunk. So you only have one R here and the rest is H. Okay, so this is what we consider as primary alcohol. Now if you move on to the next one here, see, this is your carbon. Put a asterisk here. So at first you will have one substituent, and now you have another substituent, right? So this one is just a H. So you have R and you have R prime. So this is a secondary alcohol. Okay, what about the third one? Here, the third structure here. So you can have this one off, because this is your string, and then the second one, this is your R prime, and this one is not H, right? So this one will be the R double prime. So we consider this as the tertiary alcohol, right? So all these things you need to remember when it have a chemical reaction with anything, it will give different type of product. So I'm going to explain more on the primary alcohol. So primary alcohol like this. So again, you need to look at the functional group. It is indeed alcohol, and then go and find the carbon that holds the OH, which is this one. So you're going to put an asterisk there. This is your carbon, and then find your substituent. This is your R, and the rest is just H. So this one is a primary alcohol. So since that this is a primary alcohol, it can be reacted or it can be oxidized. Means that it will undergo an oxidation process. So if you want to do an oxidation process for the alcohol, you need to add something to it, like a catalyst. So you need to put the acidified potassium dichromate. So acidified potassium dichromate, you need to add it. Potassium. please remember this. You need to have this in order for the reaction to occur. So what's going to happen to this structure? Okay, you're just going to copy back this thing, the carbon chain. You only have 3 carbons altogether. So I'm not going to do anything to the substituent. Nothing's going to happen to the substituent. This is your R, right? So you just have to copy your R. The things that's going to change here is your carbon, this carbon. So remember, at first when it is an alcohol, it have the OH. So the oxidation for primary alcohol, at first it will create aldehyde. So your OH here will turn into double bond O. And you are going to remove 1 hydrogen because your carbon should only have 4 bonds, right? So 1, 2, 3, 4. So here you will have your hydrogen. So this hydrogen will be omitted out. So you have already cut off this hydrogen, so that from OH it becomes double bond O and this H as well, right? And then since that this is an oxidation process, it means that it will have H2, 1, 2, oxidation, oxygen, O. So the subproduct will be water. So this is an aldehyde. So for aldehyde, how are you going to name it? Aldehyde, right? 1, 2, 3. 3 carbon. So 3 carbon, methanol, ethanol, propanol, right? That is for alcohol. But propanol, the third one should be propanol if it's an alcohol. So all, right? The all, you are going to change it to al. So instead of propanol, it becomes propanol. So propanol. Okay, prop because of the 3 carbon, propanol because it is an aldehyde. Alright, so what's going to happen if I want to oxidize it some more? So can it be further oxidized? Yes. So if you want to oxidize it some more, can do so. Oxidation. So you need to have the same potassium dichromate. Okay, but you need to reflux it. Need reflux. So you will change from alcohol. The first step, it will turn into an aldehyde, and the end part, after you have oxidized it some more, it will become carboxylic acid. So you're going to oxidize it. So this is your primary carbon, right? So you oxidize it the first time. You're not going to do anything to your substituent. So this one you just have to copy back. But for your carbon here, your OH should be changed to double bond O. This one remains, but this part, hydrogen here and hydrogen here, will be removed to create this propanol, which is an aldehyde. Okay, So you can further oxidize this to become carboxylic acid. Same rule, you are not going to do anything to the substituent, just copy it. Right? And some changes will be done to your carbon here. This is still your carbon. Okay. So you have this double bond O remains, but for your H, we will give an O to it. You will add this oxygen, you will add inside it. So it becomes a carboxylic acid. So how do you name carboxylic acid? 1, 2, 3. Still 3, right? Prop, propa, OIC. See? Propanoic. Prop because of 3 carbon. Propanoic. This is for your carboxylic acid. Since carboxylic acid is an acid, so you need to have propanoic acid. So remember, if it's a primary alcohol, it will first turn into an aldehyde, and then if you have excess catalyst, the potassium dichromate, and you reflux it, it will turn into a carboxylic acid. So for primary alcohol, what you can do is that if you oxidize a primary alcohol, firstly you will produce an aldehyde, and if you oxidize it some more, it becomes a carboxylic acid.